So we've reached the final part of chapter 9. So in part 4 of chapter 9, we're going to look into how we can use file streams as functions argument. Now a file stream object can also be used as function arguments or parameters. But in the case of file stream object, the function's parameter must be a reference, or we have to pass the address of the stream object. For more details on pass by reference, you can review back section 6.3 in your textbook or in the slides. So with a file stream object as function argument, you can either pass it as an if stream followed by the ampersand to indicate address, or the off stream followed by the ampersand to indicate output file stream address. So in the following example, program 9.8, you can see that the off stream object or the out file stream object is named out file and is open in main. Now the stream object is then passed to the function in out, and the in out function is then used to write 5 lines of user entered text to file. So let's look at program 9.8 and you can try this yourself. So again, we need the IO stream library, the F stream for the file stream, CSTD library to exit, to exit here. And then we have to also include the library string because we are going to declare some variable of type string. Okay, we start with defining the name of the file that we want to write into. So in this case, I name my variable or output object fname, of type string, and the name of my file that I want to create and write some contents into it, I name it list.dat. Next, I create my function prototype. So in this example, I create my function prototype as a local prototype. So this is also allowed as long as you are calling the function inside main. So you can actually identify the prototype as local. So over here in my function prototype, my function name is inout, and because my function is not returning any value, so I can put a void as the return value for my function. And again, note my argument here is output file stream followed by ampersand. Again, off stream or if stream is considered something like a data type, so your prototype contains data type and does not contain a variable. And because I'm passing the address of the object of the file, so I have to put ampersand behind my object name. So here I have off stream ampersand. Again, off stream is just like a data type. So this is my function prototype, which I declare as local because it's included in main. And then I declare my out file object, of type of stream, because now I want to write something into a file. So I use off stream. If I want to read, then I use if stream. So out file of stream, again out file is just a variable. You can name it anything you want. And then again, once you use the string, you have to convert the string into a C type string. So you have to use the .cstring method. So every time you declare a string and you need to use it with a open method or close method, anything with file methods, you have to first convert the string into C string. If not, C++ will not recognize the file name. So it has to be in the format of C string. So fname, the name of the file, convert it from string to C string, or a string of type C. And then we call the method open to open the file for writing. So this program is intended to write 5 lines of codes. Now then we have our function here. Now my function name is inout. Again, I use void because I am not returning any values. And again, function header contains data type and variable name. So my data type here is of stream or output file stream, and because I'm passing an address, I have to include the ampersand. And then this can be any variable name that will be later mapped into the variable that I pass as an argument in my function call. So over here my function, first I declare a constant value, which is the size of the lines that I want to write. So I say here I want to write 5 lines into my file, so I declare it as a constant of type integer. Okay, so the size is 5. And then I create or declare another variable called line to represent each row of line that I am going to write in my file. So this is of type string. And then I declare my counter for my for loop, so integer count here. And then I ask the user to enter 5 lines of text. So in this case, my 5 line of text is not in a loop. Okay, so the first line is not yet in a loop. So the first line, the user will enter 1 line of text, and then I go into my loop and I count and start with the starting value 0, and I check if it has reached the size of 5, and I increment the counter by 1 every single time I call my for loop. And then I use a method called getLine to get the input from the user. So instead of using cin or inFile, over here I use another method inFile, which is getLine. Okay, you can look at the description of getLine in table 9.5 later on. So getLine here is getting input from the user of type string. Okay, so here I have getLine. Alright, so the syntax is call the method getLine followed by the word cin, which is the function cin that we have been using for input, and followed by the variable name that you declared previously that represents each line of text. Okay, and then every time I get the line from the user, I want to print it out on the screen. And because I want to print out, okay, oh no, I'm not printing out on the screen, I'm sorry, this is printing out to the file. Okay, remember we are calling a file and opening it up for writing. So I am passing the name of the object of the file for writing. So every time I read the line from the user, I want to print it out and store it in my file. So I do file out, which works just like a cout, followed by the variable name line, which represents the line of text, and then an L, and then I call the loop over and over again until it reaches the maximum of 5. Okay, again getLine is getting input from the user just like cin. So the syntax is getLine cin comma line, and line is the variable which reads what is the text entered by the user here. Okay, so this is done 5 times because the first time the user enters here, the other 4 the user enters through the loop. And then I would like to print out the file has been successfully written. So if I manage to get all 5 lines entered by the user, which is entered by the user one by one, if I manage to get all 5 lines written, then I would like to return this message, the file has been successfully written. Okay, so when I go back to this slide, I am going to do a function call here. So again, my function name is inout. I have to pass the output stream object here, which I declare as outFile here, before I can actually pass that to my function here. So then I'm calling inout with the object file out or outFile. So outFile will be mapped to file out. Okay, so you can try that out on your own and see the output. So you should get an output in the file list.dat with any 5 lines that you enter. Now, some common programming errors that you may face when you're doing any file manipulation or using any file methods. First, probably the main or common mistake is forgetting to open the file before you read it. Okay, this is very common mistake. So every time you want to read the file, make sure you call the open method. Next, trying to use the file's external name in replacement of the internal file stream object. Now remember, file stream object, okay, I go back to this slide here. This is a file stream object, okay. This is a file stream object, which is a variable or an object of type of stream. And when we say about file external name, then that is actually referring to list.dat. So this is the external name for the file, and this is the object that is going to represent the file. Okay, that is going to refer to the file. Okay, next, opening a file for output. without first checking that the file with the same name has already exists. Now when you open a file, remember to open a file, the file must already exist in your directory. If not, you're not going to be able to open the file, okay, because the file is not there. How can you open something which does not exist? So make sure you do a checking, so you can use infile.fail to check whether the file has been successfully opened, right? And then sometimes when you open a file for output, for writing, you have to make sure that you're not overwriting the existing content, because sometimes you want to preserve the original file and don't want to rewrite. So you might want to give a new name if you want new data to be stored in a file. Then, not understanding that the end of file is detected only after the end of line sentinel has either been read or passed over. So when you call the end of line or EOF method, okay, the program only detects the end of file, okay, or the end of the character, which is the last character in your file, only after it has passed the end of file marker. So once that has passed, then it says that you have reached the end of the file. Next, attempting to detect end of file but using character variables for EOF marker. So variable used for end of file marker must be declared as integer and not as a character. Next, using integer argument with the seek_g and seek_p functions. Now remember seek_g and seek_p. Over here, it does not actually require any arguments, but you can actually provide arguments, but in the form of long integer constant or a variable. So you cannot use integer, you can use long integer or a variable. Any other value passed to these functions, okay, if you put anything else other than long integer or variable in seek_g or seek_p here, you'll get an unpredictable result or an error. And as a summary, okay, a data file is any collection of data stored in an external storage medium, just like USB, under some common name. A data file is connected to the file stream using the file streams open method. So this function connects the file's external name with the internal object. A file can be opened in input or output mode, and an open output file stream either creates new data or erases existing open file. That means when you open a file for writing, if you already have that file with some contents, it will be erased unless you provide a new file name. Next, all file streams must be declared as objects of either the if stream or of stream classes. In addition to any files open within a function, we have standard stream objects like cin, cout, and cerr. So these are automatically declared and automatically open when a program is executed or run. Data files can be accessed randomly using the seek_g, seek_p, tell_g, and tell_p methods. Now we do not discuss this in detail, but you can try out the methods yourself. So the G versions of these functions are used to alter the query file position marker for input file streams, while the P versions do the same for output file streams. So anything with G, tell_g and seek_g are for input, seek_p and tell_p are for outputs. Okay, next we are going to look at table 9.5, which lists down the methods supplied by the fstream class for file manipulation. So this is in your textbook page. So the getLine method that we used previously in passing the file stream object as function argument. So it is used to extract and return characters from the input stream until n-1 characters are read. So if the user enters some input, you read it until n-1 characters. And then the pick method is returning the next character in the input stream without extracting it from the stream. So it just returns the next character one by one without actually taking the whole stream. Put followed by an argument character expression. This puts the character specified by character expression on the output stream. So you're putting your characters on the screen or output stream. And then put back character expression. Push the character specified by character expression back onto the input stream. And this does not alter the data in the file. Next, ignore followed by an argument of type integer n. So n is just a variable. So this will skip over the next n characters. So if n is omitted, then the default is to skip over the next single character. So n is the size of characters. And then EOF or end of file, this returns a boolean true if a write has been attempted past the end of file, otherwise it returns false. The good, okay, we have used this before, so this returns a boolean value while the file is still available for the program to use. And it returns a false if a write has been attempted past the end of file. So this is to make sure that there are still contents in the file that we can read. Bad will return a boolean true if a write has been attempted past the end of file, otherwise false. And then finally the fail method, we use this every single time, is to check whether the file has been successfully opened or not. So this returns a boolean true if the file hasn't been opened successfully, otherwise it returns false. So good luck on trying all the programs in chapter 9, and also all the best for your final examination. Assalamualaikum.